I think it's a time factor. Certainly, there is an issue with different sequencing modalities, different sequencing methods. Like, for example, you mentioned RNA. Vime uses RNA, which we feel like it's a very temporal sequencing method. It's great for trying to figure out in the lab response, immediate response to a drug or food, but it's so temporal, it's not reliable. So if you do an RNA test today with a stool sample today, and you do one tomorrow, you're going to get completely different results. So it's really hard to pinpoint recommending a diet or a supplement based on something so temporal, right? The gene expression of the microbes.
Mhm.
With DNA sequencing, again, we're measuring the DNA of the microbes, not the humans. It's more stable. So, we see it takes 2 to 3 months to change the composition or the functions of an adult microbiome. In kids, you can see that changing within a week or two. So really fast changes in kids, which is why the science is stronger in peds and especially infants. For adults, I think this is where it's hard, right? Like to do dietary interventions on adults. It's easier in kids because you're feeding the kids. And adults is really hard to control diet and supplements and things like that. So I would say evidence is needs to catch up for the adult population and using one methodology, right? One of the issues with all these published studies every month is that they're all using different methodology, they're all using different DNA extraction kits, and that can introduce some biases up to like maybe 10%, sometimes 20%. So that's one of the reasons. But we're aiming to be the de facto gut microbiome test for adults and kids for all ages. So we're early in the game, about to approach 100,000 samples here. But I would advise if you're using a gut test, a stool test, to stick with the same stool test for longitudinal tracking. Because if you're changing tests all the time, you're not going to get the same benchmark. You're not going to get the same baseline.